Hi folks, this is a showcase of the some desert camp tent key features. I will cover the material parameters, the wind settings, as well as give a couple of tips for the usage and optimization. In the material instance you will find a bunch of parameters which may look overwhelming, but 99% of the time you are going to use only the first three groups. In the general look you control the overall look of the cloth, like the tint. You may choose to add a color to the faded fold lines. The change is subtle, but it is still nice to have it around. To hide the obvious repetitivity of the same duplicated asset, you can randomize the color with a noise texture. The texture is bound to the asset location, therefore to weaken the position, randomly offset the texture. Some assets, like the roofs, are made of patches, as they would normally be sewn in real life. You can randomize the patch's color by changing the asset location, or with the seed parameter. The next group, dust/sand, has two subparts. The first one adds the dust from top to bottom. You can change the amount of the dust, its height, and the gradient softness to your liking. Additionally, you can set the amount of the dust on each side of the cloth. Imagine, this is an outer and this is an inner side of the tent. Logically, because of the wind, the outer side will be more dusty than the inside of the tent. By enabling this parameter, you can create such effect, by increasing an amount on one side and lowering on another one. The accumulated sand is usually found in the cloth deepening and cavities between the folds. The control parameters are almost identical to the previous part. Solid color or textures is a switch between the set of three textures for the sand and just a solid color parameter. I added it purely for the optimization purpose, but you are free to switch to the solid color from the very beginning, especially if you need just a little bit of the dust. The difference won't be noticeable. To change the sand textures and its color, open the sand textures material function and make your changes there. We now have reached the most delicious part, the wind. For the wind to take effect, make sure the wind controller blueprint is placed in your scene. In the details you will find the parameters for the wind force, the gust strength, their speed, frequency and bending. The parameters related to the wind and gust act independently. This way you can create a full range of motion, starting with a uniform wind or a breeze with an occasional gust, to a full-scale storm. The wind system I use for these assets is material-based. This means you can further fine-tune it in the material instance of each asset. Here you can increase or lower the wind and gust influence and their speed depending on the cloth shape and thickness or its location. The assets inside the tent are less exposed to the wind, for example. For some assets, like this taut rope, you can disable the small frequency wind completely to create an impression that the rope is stiff and tightened. When the wind hits an obstacle, especially made of fabric, some of the wind gets through the cloth, the rest goes to the sides. The lift force lifts the cloth up. The side force offsets the cloth to the sides when the asset is aligned with the wind direction. Setting to the negative value changes the side the cloth is blown to. When the cloth is placed sort of perpendicularly to the wind direction, the side force defines whether the blown part goes inwards or outwards. The bottom gradient is useful to remove the wind effect from the bottom of the asset in the cases where the roof parts are placed close to the ground. To hang or not to hang, that is the question, and in this case, that is the option to add an extra layer of believability to the fake wind. Instead of having just a swaying cloth, enabling this option adds an extra motion to the ropes as well. Since it requires an additional texture with further calculations, I left this parameter exposed for you to decide whether you are willing to sacrifice a couple more material instructions for this small but nice effect. Gust bending, when and where to use. I would say in the stormy conditions. To make the storm look more believable, you can turn on this parameter which, with a couple more settings, allows you to bend the whole assembled tent. With min and max values, you define the lowest and the highest point of the asset relatively to the world and whether the asset is used standalone or in assembly. It will all make sense after I show you an example. Let's take this pole. The bending mask is simply a gradient mask with the lowest min value set to 0 and the highest max point set to 1. When I enable the bending influence, we receive an inclination along the wind direction. By the way, the bending effect is dependent on the gust. It means that lowering the gust strength decreases the bending. If the gust is turned off, no bending works either. Let's take it to the next step and make a tall pole out of this short one. I'm using a blueprint version of the asset for this example, and I will explain why later. In the blueprint of the poles, I also included a sand dip part for more organic blending with the environment. Uncheck the sand dip option to turn off its visibility. Back to the bending. If we set the values the same way we did for the previous single pole, the result will be far from what we expect. That's because when stacking the poles like this, the max value of the bottom pole will now become a min value for the pole above it. Since I overlap the poles, the min value of the upper pole will be less than 1, something around 0.8. Let's make it plus 1 for the max value, which will now be equal to 1.8. The third pole min value will now be 1.6 and the max 2.6. Another example. Let's keep the default values and only enable the bending for now. See how we can already spot the movement mismatches. We can go two ways from here. The first way is to use the longest pole as an absolute. Set its max value to 1 and decrease the value as we reach the smallest part. The closed side wall to 0.9. The short pole is roughly half the size of the long pole, even a bit shorter I would say. So let's set it to 0.4. The second way would be doing in reverse order. The short pole is set to 1. The closed side wall is twice bigger, so set it to 2. And the long pole is a bit longer, therefore I set it to 2.2. Done. Which way to use is up to you. However, notice how the bending effect looks more intense now. The higher max value you set, the stronger the effect. There is one more parameter worth mentioning, and which is located in another group, wind setup and debug. The wind system can be tri, two, and one-planar. While I have already set this up for every asset, there are some 10 pieces you need to be aware of. Since they are considered complex due to their multiple folds and overhung parts, the triplanar, even the two-planar wind may fail sometimes, deforming the wind in a very odd manner. Therefore, depending on the wind direction, you would need to choose a projection axis, xy, x or y, and even sometimes z axis. Well, you're probably asking yourself or me through your screen, should I copy and assign the new material instance with such a minor change every time I want to rotate a particular part of the tent or change the wind direction? A good question, which leads us to the next chapter. You may have noticed that there are two types of each asset in the 10 parts folder, a regular static mesh and a blueprint. When assembling a tent and assigning different properties, you reach a point where you would need to duplicate a material instance, sometimes even several times, to change some properties, like to set a higher or lower wind influence, switch the side the dust appears on, etc. Using the blueprints eliminates this tedious work. Each blueprint has several essential material parameters exposed, which you can change on the fly for every copy. There are pros and cons you need to consider when choosing whether to use the static mesh or the blueprint. While blueprint seems more practical, it can be more performance demanding due to how the essential material instance has to be set up. Since there is no way to control the bool parameters via blueprint, in order for these sliders to work, the bool parameter has to be enabled in the material instance in the given asset. Let's say you want to add dust on this copy and keep this one clean. Normally, you would just turn off the bottom to top dust parameter, this way also disabling unnecessary calculations behind the scene. Unfortunately, this is not possible when using the blueprint. In this case, for the dust slider in the blueprint to work, you have to keep the parameter enabled in the material instance. To hide the dust on the static mesh on the left, set the dust amount to 0 in the material instance. However, this doesn't work in favor of reducing the shader complexity. Thus, which one to use, static mesh or blueprint, is purely a per-case decision that you need to make based on your project requirements. Meanwhile, I have finished assembling a tent in the background. Now, let's fix a couple of things and make it ready to put in any scene. First of all, I hide the sand dips. By the way, you can move them to align with any uneven landscape. Secondly, let's add some sand and dust to the cloth for more realism. I want to make the inside of the tent less dusty. Make sure the control dust on each side is enabled for the parameters in the blueprint to work. I will do the same to the other side walls. Next, I'm adding the dust to a pole as well, and repeating the same process to the rest of the poles. For the ropes, I decided to add just a bit of sand. The roof has wide hollow parts that can easily trap the sand carried by the wind. That's why adding a bit of it creates a more natural look. Now it's time for the wind. Let's add it to the scene. It's windy outside, but it doesn't look like it in our scene. Let's fix it by increasing both strength and speed of the wind and the gust. Then, by adding the gust wind effect. I chose this front pole as a starting point with the max value of 1, and from here I will either lower or increase the number for the other parts. The right guy rope I left at 1. The left guy rope is a bit shorter, so 0.9 fits better. The highest point of this cloth part is even lower, therefore I set it to 0.8. The short pole is roughly half the height of the pole we started with. 0.6 looks nice. Copying the same value to other poles, guy ropes and side walls, since they are approximately of the same height. The inside pole looks twice longer than the pole we started with, so I decided to set its maximum value to 2. The roof is the easiest part because we already have all the variables. We know the highest point of the long and the short poles, so we set the max and the min values for the roof accordingly, 0.6 and 1.9. Looks like I found a potential issue I haven't mentioned yet. See how the cloth is penetrating the pole. Because the fake wind is material-based, the asset is not aware of its surroundings. It doesn't know what to collide with. As a workaround, I use a mask to prevent such intersections, like I did here. Notice how the cloth retracts from the pole, moving in the opposite direction from the wind. And then how it behaves normally when we change the wind direction. Initially, I wasn't planning on placing a pole next to this part of the cloth, therefore I didn't include it into the vertex color mask. Luckily, you don't have to paint yourself, because I had added the vertex color maps for every asset influenced by the wind to the relative folder, just in case. In this given 10th part folder, you'll find 2 vertex color textures. One has 2 masked parts, another one only one. Export the texture. Go to the Mesh Paint. Import the earlier exported textures for all LODs. Make sure B channel is selected. Now it works. Well, kind of. The weird stretches you see are caused by the cloth folds. Shortly, the mask works when the vertex normals of the mesh are aligned with the wind direction. In this case, the normals of the folds are pointed up and down, therefore they are not affected by the mask. To fix this, open the material instance and go down to the Wind Setup and Debug section, where you will find an already enabled Prevent Intersection mask. Uncheck the Use Vertex Normals. And voila, it worked! With a small thing to consider. By unchecking the vertex normal usage, the intersection mask now affects these particular parts all the time, offsetting them in the opposite direction of the wind blow. That's a bit impractical solution, and now depending on the wind direction and the placement of this sidewall, you may want to turn on or off the mask influence in the blueprint properties. That's all for this introductory video. I hope you are not more confused about the parameters than you were before watching it. See you!